Welcome to Educator.com. Today's lesson is special products. So there are a few rules for special products, and if you memorize these equations, it will give you a great shortcut into solving certain types of equations. The first special product is the square of a sum. And the square of a sum is actually the square of a binomial. And if you solve this using the FOIL method, you'll find that you get first is a squared, outer is ab, the inner two is ab, and then last is b squared. Simplify this, ab plus ab, to get 2ab plus b squared. This is the same as what you have here. So if you already knew this formula and then you saw that you had the square of a sum, you could quickly solve by just plugging in a and your b values. An example of this would be 3x plus 2 squared. So this is the square of a sum. What I have then is that a equals 3x and b equals 2. Knowing that and applying this formula, I then have 3x squared plus 2 times a times b, or 2, plus b squared. So that gives me a squared, that's 3x squared, or 9x squared. 2 times 3 is 6, times 2 is 12, so that's 12x, plus 2 times 2 is 4. And I could actually do this using the FOIL method just to show that it would come out the same. 3x plus 2 times 3x plus 2. If I multiply my first terms, I'm going to get 9x squared. My outer terms, I'm going to get 6x. My inner terms, I'm going to get 6x. And my last term is going to give me 4. And I figure that out, and it comes out to 9x squared plus 12x plus 4. So this is giving me the same answer, but more quickly. I have to go through less steps using this formula. The second formula is the square of a difference. So again, let's look at this more closely. The square of a difference would be a minus b times a minus b, or a minus b squared. Using FOIL, I'm going to multiply the first terms, the outer terms, negative ab, the inner terms, which is negative ab, or negative ba, same thing, and the last two. Simplifying to get negative 2ab plus b squared. Applying that to an example, I could use 4x minus 3 squared. So I look at this, and I need to figure out what my a is, and it's 4x. b is 3. It's not negative 3, because the negative is already accounted for in the formula, so b is just 3. I go ahead and plug in these values into this formula, a squared minus 2ab plus b squared. So a is 4x. 4x squared minus 2 times 4x times 3 plus 3 squared. That's going to give me 16x squared. Negative 2 times 4 is negative 8 times 3 is going to give me a negative 24 x plus 9. Okay, again, I could have used FOIL. I could have written this out as such and then multiplied all that out, but I would have come up with the same answer and it would have taken me longer. So this is the formula for the square of a difference, another important formula. The last one is the formula for the difference of two squares. The difference of two squares would be in the form a plus b times a minus b, using FOIL. First is a squared, outer negative ab, inner ab, last b squared, minus b squared. Okay, this gives me a squared. Negative ab and ab cancel out. That drops out. And then I have minus b squared. Applying this to an example as well, I could have something like x plus 3 times x minus 3, the difference of two squares. So I look and I have to find my value for a. The first term is x, b, it's 3. Not negative 3, it's just 3. I look at my formula, and that gives me x squared minus 3 squared, which equals x squared minus 9. And this is certainly much quicker than going through and doing FOIL and multiplying everything out and then adding. So this is another shortcut. Applying these to examples, the first thing is to recognize which situation I have and which formula I need to use. And I look at this, and this is the square of a sum. It's the square of a sum because I have a sum, 2x plus 5y, and I'm multiplying it by itself. Okay? When I have the square of a sum, that is something in the form a plus b squared. I'm going to come up with an answer in the form a squared plus 2ab plus b squared. First thing is to figure out what my value for a is. My value for a is 2x. My value for b is 5y. So remember to include the variable. Then I just go ahead and I plug it into this formula. Write this back up here so I can really see what I'm working with. A squared would be 2x squared plus 2 times a times b plus 5y squared. Okay, working this out, 2x squared would be 2 times 2 is 4x squared plus 2 times 2 is 4 times 5. That gives me 20x y. And then I have 5y squared, so that gives me 25y squared. So I have 4x squared plus 20xy plus 25y squared, and I got that very quickly using my formula for the square of a sum. Second example, I look at what I have and I see, okay, I have 3p minus 7q. So it's a difference, and it's squared. So what I have here is the square of a difference. And again, I could use FOIL. I could write this out, do first, outer, inner, and last. Or I could just remember that when I have the square of a difference, which is this, my answer is going to end up in the form a squared minus 2ab plus b squared. First step is always to determine what a and b are. A is 3p, b is 7q. Remember, it's not negative 7q. I already have the negative. That's part of the formula. It's just a and b for this situation. So I go ahead and write my formula over here again. So it's where I can really use it. And I know that I have a equals 3p. That gives me 3p squared minus 2 times a, which is 3p, times b, which is 7q, plus b squared, which is 7q. 3 times 3, that's 9p squared. So it's 9p squared. Then, get this out a little bit better, 9p squared. 2 times 3 would be 6 times 7 is going to give me 42. So there's a minus 42 PQ. 7 times 7 is 49 Q squared. So what I had was the square of a difference. So I used my formula a squared minus 2ab plus b squared, where a is 3p and b is 7q. Plugging in those values gave me 9p squared minus 42pq plus 49q squared. So this is a very useful formula. In my third example, I see that I have the difference of two squares. I have the difference of two squares. So my formula for the difference of two squares is as follows. If you have something in the form a plus b times a minus b, you're going to end up with a squared minus b squared. First step, look at my formula and figure out what a is. And it's 4m squared. What is b? It's 9n squared. Now I plug that into this formula. A squared. So that's 4m squared squared. This is a squared minus b squared. B is 9n squared. So I've got b, and I need to square it. Then I just need to simplify this. 4 times 4 is 16. I have a power raised to a power. 2 times 2 is 4. Minus 9 times 9 is 81. N squared raised to the second power is n to the fourth. So again, I recognize that I had the difference of two squares, and the formula that I would need is a plus b times a minus b, the difference of two squares, equals a squared minus b squared. I then determined that a is 4m squared and b is 9n squared to come up with this result. This example is more complicated, but I can break it down first just looking carefully at what they've given me. This right here is the difference of two squares, and this is the difference of two squares. So I have the difference of two squares times the difference of two squares, the product of those two things. Starting out with this one, the difference of two squares, I'm going to use my formula a squared minus b squared, where this is a and this is b. So first, write out my formula right here, and I'm going to say that, okay, a is 2x, b is 1. Substitute these values in. For a, I'm going to have 2x squared minus, so that's 2x squared, minus 1 squared. Okay, 2 times 2 is 4, so that's 2 squared, and then x squared minus 1. Well, I only took care of this part, but this is the same. These are the same. So I've actually got the product of this, 4x squared minus 1, times 4x squared minus 1. So for my first step, I worked with the difference of two squares, this formula. I got down to here. Now, what I see is that I have the square of a difference. I have the difference multiplied by itself. So recall this formula. I have a minus b times a minus b, and that's going to give me a squared minus 2ab plus b squared. So again, I could have used FOIL, I could have multiplied it out, but by recognizing this formula, I can work the problem more quickly. Again, my formula. Figuring out my a's and b's. A is 4x squared and b is 1. Substitute in. For a squared, I have 4x squared, and I need to square that. Minus 2 times a, which is 4x squared, times b, which is just 1, plus b squared. Simplifying this. 4 squared is 16. X squared, it's the second power. It's 2 times 2. That's x to the 4th. Negative 2 times 8 is 8 times 1. It's just negative 8. X squared. 1 squared is 1. So looking at this initially, it looked kind of complicated, but when you broke it down into its parts, I had a formula for this first section, a squared minus b squared, recognizing that this is the difference of two squares. And I applied that formula to come up with 2x squared minus 1 squared, or 4x squared minus 1. I recall, though, that I had this twice, the product of this. So I had 4x squared minus 1 times 4x squared minus 1. And this is the different square of a difference. This is a square of a difference, a minus b squared. So I use this formula from here on out. A squared minus 2ab plus b squared, found my a and b, substituted in, and got my answer. That concludes today's lesson. I'll see you again on educator.com.